Before we continue with the counterargument, I just wanted to share that more experiments are coming soon. I bought myself a box filled with experimental equipment at the flea market. This is pretty old stuff and might need some oiling, but it is specifically designed for demonstrations in physics classes. I've been looking for this for ages, as it is pretty hard to find and mostly pretty expensive. I was lucky to buy this whole set for only 30 euros. Let's see what we can do with this stuff.
So you know you're going to get one velocity here. So if I release one spring, push the object here to smaller mass, I'll get one velocity. Now if I release two springs, then I will get 2 units of velocity. So whatever the velocity is, it'll be twice the velocity. Perfectly consistent with Newton's second law. I mean, what he said right under the second law was twice the force, twice the motion. 3 times the force, 3 times the motion. So clearly he understood momentum works.
And clearly you don't understand what he meant with that statement. So Gary says twice the force, twice the motion, 3 times the force, 3 times the motion. And Gary interprets that as if I double the force, the object's final speed doubles. That's not what Newton meant, and it's not how Newton's laws work. In Principia Mathematica, Newton wrote that motion, momentum, is the product of mass and velocity, and that forces cause changes in motion, i.e., changes in velocity. He never said twice the force, twice the velocity. He said, translated from Latin, the change of motion is proportional to the motive force impressed and is made in the direction of the straight line in which that force is impressed. Newton's Principia, in the 1726 edition, states Law 2 in Latin as mutationem motus proportionalem esse vi motrici impresse, et fieri secundum lineam rectam qua vis illa imprimitur mutationem motus equals a change of motion. Proportionalem esse equals is proportional. Vi motrici impressae equals to the motive force impressed. Et fieri secundum lineam rectam qua vis illa imprimitur equals and takes place along the straight line in which that force is impressed. So that full Latin clause is the canonical Newtonian statement of the second law in his Latin original. That Latin is usually translated as a change of motion is proportional to the motive force impressed and is made in the direction of the straight line in which that force is impressed. In more modern phrasing, one often restates it to include the idea of momentum as the change in momentum is proportional to the impressed force and occurs in the direction of that force. And we know that motion equals change in momentum, according to Newton, because of the following definition written by Newton. In the Principia, Newton defines quantity of motion, modus. The measure of motion is the product of the mass and the velocity of the body. That's exactly our modern momentum. P equals mv. Force, vis impressa. The cause that changes the motion of a body is called force. So already, Newton is defining motion as momentum. That's why any change in motion is literally a change in momentum. Okay, so now Newton wrote in the Principia Book 1, Definition 8, Scholium, if any force generates a motion, a double force will generate double the motion, a triple force triple the motion, whether that force be impressed altogether and at once or gradually and successively. At first glance, it seems like he's saying double the force, double the velocity. But that's not what motion meant to Newton. In Newton's own words, definition 2 of the Principia, the quantity of motion is the measure of the same arising from the velocity and quantity of matter conjointly. So his motion equals mass times velocity equals momentum. When he says double the motion, he means double the momentum, not double the speed. Newton's saying a force produces a change of motion momentum. If you double the force, you double that change in momentum. If you triple the force, you triple the change in momentum. It doesn't matter whether the force acts all at once or over time. The total impulse, force times time, determines the total change in momentum. That is exactly the impulse momentum theorem. Not F equals mv and not twice the velocity. All right, let's now unravel why his second law boils down to F equals ma, which Gary rejects. Step 1. Start with Newton's own meaning. Newton said, force causes a change of motion. He defined motion as momentum. So in symbols, force equals difference in momentum over difference in time. Step 2. Write momentum out in full. Momentum is P equals mass times velocity. So when you expand dp over dt, you get force equals the difference of mass times velocity. over the difference in time. Now notice the term difference of velocity over the difference in time. That literally means how quickly velocity changes with time, and that is precisely the definition of acceleration. It's perfectly logical, don't you dare to call it baby talk. But as always, you will find extremely lame excuses to deny this cause you're pathetic as fuck. Now, one last thing for why we use F equals ma instead of F equals dp over dt. When we use F equals dp over de, this always applies even when the mass changes. However, when we use F equals ma, this only applies when the mass remains constant. In most everyday situations, cars, balls, people, springs, the mass of the object doesn't change significantly, so F equals ma works perfectly. That's why in almost all classical mechanics problems you see in school or textbooks, we use F equals ma. However, there are real situations where the mass changes over time. In those cases, you cannot use F equals ma directly. Instead, you have to use the general form. Examples: rocket in space. The rocket burns fuel and ejects it as exhaust. Mass decreases, so you must use the full formula to get the correct acceleration. Leaking cart or dropping sand from a moving container. Mass decreases gradually. F equals ma alone won't describe the motion. And there you go. But as always, you're unable to concentrate on every sentence being said, and you will keep denying that rational counterarguments are being made, and you'll keep begging for someone to argue with you. This is pure psychology, and that's your problem, not ours.